All right. So again, real quickly, retest Wednesday morning, not Tuesday morning, unless you want to test Tuesday morning in Skurhawk's room. All right. So in chapter 2, here we are, finally in chapter 2. We shored up our algebra skills in chapter 1, kind of got the rust off from the summer, from the pandemic. And now we're in chapter 2, which is kind of the big anticipatory chapter before the rest of the year. Okay. What chapter 2 does is it goes through each section at a time and it analyzes some trait or characteristic of functions in general. Okay. Some characteristics that we look for in each function. In chapters 3 and beyond, then we apply these characteristics, these traits to other types of functions like exponential functions, logarithmic functions, rational functions, and then the second semester is primarily trigonometric functions like sine and cosine and tangent, SOHCAHTOA. Okay, so every time we encounter a new function family, like I just mentioned, we're going to be analyzing it from the perspective that we gain in chapter 2. Now, a lot of the stuff in chapter 2, especially today, you might get a little bit bored. You might, oh my gosh, we did this, like, oh, I already know this stuff. Why am I here? Well, that's true, but you know how I kind of operate by now, right? I like to analyze the obvious. I like to scratch what looks like it's the surface and look underneath there, because you got to make sure you really understand what's going on from just a thorough perspective, because we're about to build upon that. And if you think we're going too slow now, you also know that things will get pretty spicy pretty quickly, right? Yeah, so basic, 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 and then boom, you know, we explode into greatness. So enjoy the pace today. Not that it gets hard. Spicy's not hard, right? Spicy, that's like flavor, right? That's where it gets fun. And, you know, we do it from the safety of a room that has plenty of water. So, you know, if you need to cool the mouth down, right? Yeah. Oh, milk works as well. Bread. Yeah. I don't have milk or bread, but yeah. What's that? A mustache? Oh, a bread stash. Oh, that would work. Yeah. Like those breadsticks from Olive Garden, right? Yeah. Like I just came from the Mexican restaurant next door and it was too, can I have 3 orders of breadsticks to go? No, I don't need a bag. Just shove them in my mouth. Right. Good stuff. Anything else? Oh, thank you. This shirt came in the mail over the weekend from England. Yeah, I ordered it straight from the Iron Maiden website. I'm going to bring back kind of an old tradition that I did a long time ago. I'm going to call it for myself Metal Mondays, primarily like Maiden Mondays, but because I have like a bunch of Iron Maiden concert shirts, and my wife is like, "You can't wear those out in public because you're a teacher and you'll scare the children," right? Yeah, you know, because their mascot Eddie can be doing things, and she's probably right. But here's the thing. She leaves in the morning before I leave. So I can get dressed like a normal teacher. And then when she leaves on Mondays, I can just put on a shirt. She'll never know about it, right? So I'm going to do Metal Mondays. And then on Tuesdays, I'm going to bring back what I used to do. It's called Tie Tuesday. It started because Mr. Wenzel wore a tacky tie every Tuesday. And we started emulating him. So it started as Tacky Tie Tuesday, and then it became just Tie Tuesday. So I'm going to wear a tie every Tuesday, okay? Absolutely. That's a good looking tie. Yeah. I make my own bow ties, so I have like 60 of them. So I'll just wear typically bow ties. Wednesdays are going to be Western Wednesday, but this Thursday is also Western Thursday. But every Wednesday I'm going to do Western Wednesday, maybe a bolo tie, maybe some kicker boots, you know. And then Thursday I think I'm going to do like Aloha Thursday, like Hawaiian shirt Thursday. I got a bunch of Hawaiian shirts too that are pearl snap Hawaiian shirts. And then Friday, of course, is Spirit Friday. So then it's like Unicorn Friday. Unless we have a Thursday game, right? So anyway, that's just what I'm going to do. Back when I did Tie Tuesday back in the day, it kind of caught on. And a lot of people started wearing ties on Tuesdays. So whatever. If it catches on Metal Monday, it's good. If you're not into metal, you only have like a Ronnie Millsap shirt or something, country west, then that's fine. You can call it Concert Shirt Monday. Music, there you go. I was trying to think of a more Music Monday. Yeah, Music Monday. Nice. See, Bluford, Music Monday. This guy, if you need something coined, go to him. Yeah, go to him. That's Standifer, by the way, if you're watching the video in China. Because they do. In Shanghai, I got an email. I'm serious. Yeah. Hi, Shanghai. I don't know. Hi. Yeah. This, by the way, is Japanese writing. It means strategy. Okay. Yeah. Anyway, chapter 2.1. We're going to be looking at algebraic domains of functions, okay? Domains are very important. When we walk up to a function, it should be the first thing we consider. But because we're scratching the surface, we need to first talk about what a function is, okay? Because you studied functions since Algebra 1. You had y equals, and you were getting used to it. And then your teacher took away the y equals and replaced it with f of x. And you're like, what the, you know? So what is a function and why do we use them? Just without looking at the notes, just think to yourself like an association game. Like if I say a word, what's the first word that you think of when I say that? So think about it for a second. I'm going to say the word function and just blurt out with the first thing that enters your mind. Ready? 1, 2, 3. Function. Conjunction, function. Okay, I didn't hear what I was looking for. But that's okay. That's okay. Somebody second period said LeBron. LeBron is in LeBron Howard? No, LeBron James. Oh, anyway, he told me why. It didn't make sense to me, but it made sense to him. How about I kind of hypnotize you and try to draw it out? You think we can do that? Like, yeah, because there's something there. Like most students, when they study functions, they get out of there thinking, okay, this every time, this every time. I'm not going to hypnotize you, but let me guide you towards what I want you to maybe pull out from the recesses of your brain. Let's say you're staring at a graph, right? Not a giraffe, but a graph. How would you know just by looking at the graph if it was the graph of a function or not? Straight line. Now we're getting somewhere. Something about a straight line. Linear straight line. Linear straight line function. What do we do with the straight line? How does the straight line thingy worky? Anyone? Something with the straight line. Now we're getting into the definition. That straight line can only touch the graph at one point. But there's all kinds of straight lines. What kind of straight line were we using? Don't say blue. It's blue, right? What kind of line? A straight. Let's say this, the V word. It's a vertical line. Oh, that's important. And we tested the graph with the vertical line from left to right. And what did you say? It could only touch the graph once, right? That's it. What do we call that when we test the graph with the vertical line from left to right? Vertical line test. That's what I'm trying to get out of y'all. That's what most people remember. They hear function, they think vertical line test. Vertical line test is associated with a function. Now, the reason the vertical line test works is because, like you said, it's only going to be a function if it touches the graph in one place. And I'm going to add to that or less. It doesn't have to touch the graph at all. But if it does touch the graph, it's no more than one. Okay, we'll modify that. No more than once. If it touches the graph more than once, twice, 3 times, 4 times, then it's not a function, right? So that is important, as we shall see. So let's go back and think of a real common trope that people use to define a function. You probably saw this in Algebra 1. It's a little machine. It's kind of like a little wood chipper, okay? You have an input. Here's your rule, f of x. But you have things that you could drop in the top. These are your inputs, right? Drop something in the top, and then f of x manipulates it, changes it possibly, and then spits it out, right? Output. Inputs and outputs. Now, usually the inputs we call x, but they could be y values. Not typically, it confuses people. Most of the time, if they're not x, they're t values because we use time. Your outputs we typically call y's or f of x itself, right? Those are your outputs. And f of x manipulates it. Now, in math, f of x is like usually an equation, right? Or it's a mapping, as you'll see, that transforms something. It's not like an oven or something that makes the bread rise, but that could be considered a function as well. Now, what are we allowed to put into our little machine? Well, we could put anything into the machine that's within our reach or grasp, yeah, within our realm, right? Within our kingdom, within our Domain. There you go. That's the word I was looking for. The collection of all inputs that yield an output is a domain. Okay? And it should make sense because it's within our grasp. It's within our domain. Now, we are free to choose anything we want to put into our machine, independently of any other choices. So the input is also called the independent variable. You can choose anything independently to put into your machine. It's your choice, okay? Independent variable. But what you get out now will depend on what you put in. So this would be called the dependent variable, right? If you think about a wood chipper, I pick up a log, I get wood chips out, right? So what I get out depends on what I put in. Well, what if I put in like giant pieces of styrofoam? I'm not going to get out wood chips, all right? I'm going to get out styrofoam chips, if you will. So the dependent variable, what you get out depends on what you put in. Now, because you can put anything in, you're going to get out a whole variety or myriad of outputs, or a whole what of outputs? A whole range. There you go. So the range is your collection of outputs. Domain, range, domain, range. So notice the parallel here. You have inputs and outputs, X's and Y's, domain and range, independent variable, dependent variable, okay? Now, there is a larger set of inputs bigger than the domain, and there's a larger set of outputs bigger than the range. You don't have to know these, but there's a larger set called the pre-image, right? What types of things can I put into a wood chipper? Well, I know I can put in a wood chipper or a log into a wood chipper to get wood chips out. I can put styrofoam in there. But are there certain things that really don't go well into a wood chipper? People actually go well into a wood chipper. I know it's sad to say, but if you've seen the end of Fargo, right? Yeah, they shouldn't, but it works. But I was thinking more along the lines of, what if I had like a big old metal pipe and I stuck that in the wood chipper? It would break the machine, right? I'm not going to get metal chips out. You need a metal chipper for that, silly. So I would say then that a metal pipe would not be in the domain, okay? It's in the pre-image. It's sitting on the ground next to the logs. It's there in the beginning, but I'm not putting it in, okay? So it's not in the domain. It is in the pre-image. There's also a larger set on the outputs of the range called the image. So if you think about the wood chips spitting out onto the pile and the pile's getting bigger, there could be like a rock that's next to the pile that was there before, right? That rock did not come out of the wood chipper, right? You're not going to walk up and say, how'd that rock come out of that wood chipper? Oh, it must have been there before, right? So that rock would not be in the range, but it would be in what we call the image. So you don't have to know that, but I want you to be aware of it. Sound good? All right. We're concerned with domain and range. What values are we actually going to plug in that give us an output? Now, let's think about now why we study functions. The thing of having no more than one output is very, very important. Imagine going to the HEB, right? You're going to the HEB. And I'm going to go by myself, because if I go with my wife, I'm going to get in trouble. I push the basket too slowly. She needs it when I'm not there, because I'm looking at like, there's a lot of ketchups here, you know. But I'm going by myself. And in the fruit section, they have like an exotic fruit section where you can buy like dragon fruit and big old round things that are this big. Yeah. But they also sometimes carry pomegranates. So imagine that I'm going to the HEB just for pomegranates. That's it. And I look at the unit price, and it's either like per pomegranate or per pound. I don't remember. But there's a unit price, right? So I know how much I'm going to pay roughly. And I carefully select 5 pomegranates. That's it. And I hold them awkwardly in my arms, you know, so they don't fall, because I didn't get a bag, because I'm stupid. If my wife were there, she'd be like, use a bag. I'm like, that's smart, right? But I'm just walking with 5 pomegranates. I put them down at the register, and I'm kind of expecting what the price is. Now, if you get there and the cashier rings it up on the register and reads what comes back, and it might be one of y'all because they hire a lot of students, put yourself in my shoes. If the cashier said, that'll be $2.20 or $8.50, what would you say? Yeah, give me the 220, please, right? I'll pay $2.20, right? And then she'll be putting them into bags, or he'll be putting them into bags, for you. And while you're trying to pay and the cashier's trying to bag them, I hope another conversation would come up. Like, hey, why did you offer me two different prices? And the cashier's like, yeah, I don't know. That's kind of weird. It just came up that way. I've never done it before. I don't understand why he did that, right? That would never happen. You know why? Because it doesn't make any sense. You're never going to take 5 pomegranates up there at a unit price and be offered 2 different prices for it, because it doesn't make sense. It's not a function. One independent choice of an input. No one coerced me to choose pomegranates. No one coerced me to use 5. I independently chose them. That's one input. There can be no more than one output. So having 2 outputs doesn't make sense. Most things in the real world behave that way. In the real world, there is a fake world where you can have 2 different outputs. And by fake world, I mean just weird, whack, like subatomic particles and stuff. They kind of don't behave the rules of logic or physics. There's a slight probability, believe it or not, that if I lean on this wall, I'll fall right through to the other side. And not from pushing it over, just by a random arrangement of the atoms in my body. It's quantum theory, so things behave a little differently there. But we're talking about mostly in the real world. Yeah. That's why we study functions. Got it? We study functions because it helps us make sense of the world. And if we can apply some type of rule, if we can figure out the rule, we can use it to predict and project and anticipate, right? Like, let's have bandwidth before we give everybody iPads, right? Let's build big robes to have in place before the crowds get here, right? That's all good things, right? So functions. So let's go ahead and give ourselves the verbal definition of a function. There's several ways we can represent a function. This is the verbal definition, okay? It's in a box. Anytime you see something in the notes that's in a box, it means it's important, right? Like donuts. Donuts come in a box. Donuts are important. A function is a relation, and that's an important word. Not relationship. They're not like seeing each other. It's a relation between 2 variables. It could be x and y. Could be u and v. Could be any 2 variables. Whereby, that's a good word, each independent variable in the domain maps. Okay, if you want to know what maps means in this case, it means goes to. Okay, where each variable in the domain maps to or goes to. And then here's where you might need to adjust your definition a little bit. No more than one. No more than one dependent variable in the range. There doesn't have to be an output. It can still be a function. I'm not putting the metal pipe in, okay? But if there's an input that has an output, we call that the domain, and the output collection is the range. All right, so there's the verbal way. There are several other ways. Here's one way we can represent it numerically. This, of course, would be like a table of values straight off of your TI-84 calculator. All right, y'all know how the table of values work. You have a set of essentially ordered pairs. So if you wanted, you could write this like this. You would put a set, and you would list input, output, input, output, input, output, so on and so forth. Okay, you would keep going. So that's just another way to represent something numerically. Numerically just means numbers, okay? So today we're going to learn how to identify by a set of data points, by a chart, by a table, by even a mapping that I'll teach you. Is it a function of X or is it not a function of the independent variable? We'll see. This one, in fact, is, okay? You may recognize it by the data set, but if you don't recognize it by the data set, you'll recognize it by the big smile, right? You're never fully dressed without a smile, right? It's because he's in a math class and the Comal County Fair is coming. So graphically, how do we determine if something's a function or not? That's what I was trying to pull out of y'all. That's the vertical line test. And it's so easy on Notability to do a vertical line test, because all you got to do is snap yourself a vertical line and look, you can animate it like this. Does this touch the graph more than once at any x value? No, so it passes, right? Before notability, I had to stand up here with my forearm and go back and forth. Does my forearm touch the graph? And more than one spot at any given time, boo-boo. And when I do that, I kind of feel like one of those ducks at the Comal County Fair, one of those games that you play where you shoot them with like BBs. Nah, don't shoot. I'm just doing the vertical line test. And it's a real fear I have, because last year, y'all are not amused, but I ain't either. This is no joking matter. Last year, that window right there by my desk got shot out by high-powered pellets. And I was like, man, just tell me. I'll give you an A. You don't have to take me out. We had to relocate for a while. They did a criminal investigation and put in a new window. But it took a while. Yeah, it's scary. That window got shot out. It wasn't that window over there. It was the one right kind of where my head sits, So anyway, it just comes with the territory of being a math teacher. I guess. Dangerous work. Like a duck at a midway game. We can also represent it this way. We call this the analytic representation or the algebraic representation. Either way, they're kind of interchangeable. Now, a word about the analytic, because this could be real easy to identify, real easy. If you ever see that, f of x, that is designated for a function and a function only. Okay? You're not going to use f of x if it's not a function. Now, of course, we can use other names besides Franklin of x. We sometimes use Geraldine of x, right? G of x. Hortense of x, is another one. Those are the three most common, F, G, and H. But it doesn't even have to be x, right? If you're in a physics class, you might look at a function v as a function of time, right? Where time is the independent variable. Time makes a really good independent variable. Try stopping time. It's not going to work. This would be like velocity, instantaneous velocity, okay? So if you see this notation, you know it's a function. The trick is trying to recognize by the equation if there's not a function notation. So if you have like y equals x squared instead of f equals x squared, how are you to know if you don't know what the graph looks like? Here we do. If you don't know what the graph looks like, how can you tell just by the equation if its graph passes the vertical line test eventually? I'll teach you that tomorrow, okay? After we do some more warm-up voting, all right? Yeah. All right, so let's go ahead and jump down to number one, the example one. It says determine if the following represent functions if or not. Explain why if not. Now, I've been meaning to change this, so we'll change this officially on the video. Go ahead and cross out domain and range. The reason why you can cross out domain and range is because domain and range kind of assumes that we already have a function. We don't really use the term domain and range unless we're talking about a function already. So let's just change it to input. Whoa, easy there, Buster. There we go. Input and output. Now what you could do is you could copy this, and let's just change it all the way across. A, B, C, and D, okay? Inputs and outputs can be part of things that are not in the domain, like the pre-image and image. So that works a little bit better, okay? All right, now we have inputs and outputs. This right here is called a mapping. It's a little bit different than a chart, but I think it's pretty intuitive as well. If you look at your inputs, the arrows map an X value in this case to a Y value. If you want to call your inputs X and your outputs Y for convenience, that's fine. That's what we typically do. All right, so just by looking at this mapping, does it represent a function of X? Yes or no? Yes? I would agree, yes. I'm going to put an exclamation point because I'm always excited. My English teacher always told me you can never write excitedly simply by adding exclamation points to your sentences. And I was like, you're right. You need to create the excitement in your words, not in your punctuation. I guess. Whoever said yes, or whoever was thinking yes, what criteria did you use? How can you summarize it for someone who's trying to do their own investigative work here? Each input has one output?
They don't have multiple outputs. You know what I mean? The numbers on the right only have like they only have one.
Oh, okay, okay. Y'all are both kind of, yeah. The numbers on the right only have one arrow going to them. If they were to have two arrows going to them, that wouldn't work. Hold that thought. Let's come over to B. Hold that thought. Look what happens on B. You have one Y value. It's got all the arrows going to it. What a popular -6, huh? Right? What a popular -6. Is that representing a function? Well, let's see. Let's write this as an ordered pair. If we think of inputs as X and outputs as Y, this would be the ordered pair -3, -6, and then -2, -6, and then -1, -6, so on and so forth. If you were to plot these, -3, -6, -2, -6, -1, -6, 0, -6, 1, -6. If you connected those dots, it would make a horizontal line, wouldn't it? Does a horizontal line, whoa, does a horizontal line pass the vertical line test? Does it pass the vertical line test? I think it does, right? Yeah, if you cruise left and right, it only touches the graph at one point everywhere. See that? You can animate it. Whoa. So I guess this would have to be a function, right? But it's not because the Y values have a unique X going to it. It's because the X's only go to one place, right? And that's kind of what y'all said in the beginning. So here would be kind of the easiest criteria. If you're just looking out for X's to make sure they don't go somewhere more than once, just say yes, no repeated inputs. That's the easiest way to look for it. If you have more than one arrow coming off of an X, it's not going to work. Now, notice in this case, let's go back to the pomegranate analogy. I have the same input repeating for multiple things, and that's okay. So if you think of my output for the pomegranate example, that was $2.20. Are there other things in the store that I might be able to go get and put up at the register that aren't 5 pomegranates that might come out to $2.20? Yeah, probably a lot of things, right? A Three Musketeer, a Twix bar, and a Coca-Cola, right? Healthy breakfast, or maybe some banana chips or whatever. I don't know. There are lots of things that can add up to $2.20. So you can have repeated outputs, no problem. They just have to come from a different input. No repeated inputs. So now if we go back to example 1, there's no repeated X values and there's no repeated Y values. But the reason it's a function is there's no repeated inputs. Yeah. No repeated inputs. Now, someone in first period said, hey, can we put no inputs repeat instead? And I'm like, yes, that's the same thing. But it's actually a little better, in my opinion, because it saves you 2 letters. You don't have to write the ED. So that person's already thinking economically, right? Efficiently, like a mathematician. But yeah, no repeated inputs. So if you want to highlight them, here's what we're looking at. We just look at that. There's 2 arrows are not coming off of there. Same thing here. Only 1 arrow coming off of there. All right. How about letter C? No. Who's the culprit? 1. Make up your mind. 1. What is it? 1. All right. This would be like you go to buy one pomegranate, and you go up to the register and the cashier says, that'll be free or $15. And you're like, well, yeah, you know, HEB is a really good company. They give back to the community. They do a lot of great things, and they can't do that without money. In fact, they have a lot of employees. A lot of them are students, give them flexible schedules, and they can't really pay their employees unless they earn money. So when you tell me 0 or 15, I'm sorry, but I feel compelled to still take 0, right? I'm not paying if that's an option, right? Get your money some other way. This doesn't make sense. That conversation would never happen, right? So yeah, no. X equals 1, if you want to call those again X and Y. X equals 1 maps, that's a good word, maps to 2 different values. You're not going to ever see a single X value mapped to the same value more than once. That's repetitive. We don't need to. One arrow, one listing, that's it. Listed twice, okay? All right, what about letter D? Function or no? Yes, very good. Do we have any repeated X values? Nope, we don't, okay? We don't. What about 16? He doesn't go anywhere. Is that okay? It is okay. 16 would be like the giant pipe that's laying on the ground next to my wooden logs. It's there. I can see it. It's in the pre-image, but I'm not going to put it in the wood chipper. Okay? So this is a function because there's no repeated inputs. Okay? Yeah. Now, let's take it one step further here. Let's go ahead and practice writing our domain and our range, because that's what we're going to do eventually. The way that we list the set of domain is we put big D colon, not equals, big D colon. And what we do in this case is we'll list it in set notation. What do you think the domain is for letter D, little d, the one we just did? Yeah, it's the collection of inputs, right, that actually go somewhere. So if you're going to list them, -3, -2, -1, 0, 1. We call this a roster notation, much like a sports roster. It's just a list of the team players. Who's playing for team domain? -3, -2, -1, 0, and 1. Is 16 in the domain? No, he didn't play today. Right? He's in reserves, right? Sitting out today. And then the range, big R colon, not equals, colon, it's the list of outputs. So again, that would be brace, -6, -1, 0, 3, 15. Now, if I had another number sitting over here like 24, 24 doesn't have any arrow going to it. So it would be in the image. That would be like the rock or the snake that's sitting by the wood pile that didn't come out of the wood chipper. Okay, so it wouldn't be in the range. So you can have elements, you can have things that are sitting out there that are not part of the input or the output set. So they're not in the domain or range. Okay. All right. Let's do one more here. Since B was a function, let's go ahead and list the domain and the range real quickly. The domain big D is the list of highlighted things: -3, -2, -1, 0, and 1. And then the range, what do you think the range is? -6? Yeah, do you think we have to list it 5 times? -6, -6, -6?
Very excited about that.
If you're very excited about it, the answer is no. Like if you're writing it as ordered pairs, yes. Parenthesis, -3, -6, parenthesis. That's an ordered pair. You need it in there. But if you're just listing inputs and outputs, -6, if it's in there once, you don't need to list it again, okay? Even if you're excited. I mean, you can, but maybe then you trace right on top of it, right? -6. That is, yeah, look at that. You can barely even see his, got to come back in and trim a little bit up, right? There you go. There you go. Now, yeah, oh, a little space right here. There we go. There you go. Like a little haircut, right? My wife says I need one. Nope, sorry, my hair, right? Steven checked his phone, said didn't have to cut it. It's all right. You owe me a song. That's okay. Yeah, it's okay. Good. Pep rally Thursday, center court. All right. You sing the wrestling song, right? I'm on the wrestling team and we wrestle every day. Do rah, do rah. I don't know the song. Work on it. Okay. All right. Let's look at letter E. This, of course, is another way to represent a function using data. All right. But it's listed as an ordered pair. Now, a quick word about ordered pair. we know the ordered pair to be x comma y, but it doesn't always have to be xy. It could be time t comma v, velocity, or it could be n units of production comma p, profit dollars, right? But here's what we do know. By convention, always the first one listed is your input, right? By convention, the first one listed is always your input. And the second one listed is always your output. Whatever variable you want to call them, okay? So there you go. Does this list then of ordered pairs represent a function? No. Why not? There's two sixes, right? 6 goes to 1 and 6 goes to -5. I don't think so. No. X equals 6 repeats. Let's just say that. It goes to two different values, okay? It's still a relation, but not a function. Nice try. All right, how about letter F? Function or no? No, and it's because -1 repeats, right? Good, it's because 5 repeat. I can't even trick y'all, right? Like the gingerbread man. Can't fool y'all, I'm the gingerbread man, something like that. So this would be no, x equals 5 repeats. The gingerbread man was not a nice cookie. He was not. But he was fighting for survival, I guess, so you can't blame him. All right, now, real quickly here, I know the bell's going to come on, but this is the easy part, right? Are these functions or not? Do they pass the vertical line test? Let's do it real quickly. A does pass, right? So we're just going to say yes, vertical line test. That's what VLT stands for. How about B? No, okay? Right there, booms. This one is fails the vertical line test. Now, I do want to point this out. Right there at the origin, it only touches at one point. That's called a tangent line. Everywhere to the right of 0, it touches twice. But at 0, 0, it only touches once. Also notice that out here to the left, it doesn't touch at all, right? That would be like not having an output, and that's okay. That's the lead pipe. But because it fails once, that's all it takes, it fails altogether. All right, what did y'all say about D? Yes or no? Yes, vertical line test is good. What about E? Yes or no? Yes, vertical line test. What about F? I will wait. Look at this. Yeah. Look, so an open circle means not there. That's okay. It doesn't have to be in the domain. One output, one output, one output. The question is really at the origin. Does it touch in more than one place at the origin? It's an open circle at the bottom and it's a closed circle at the top. Is that okay? Yeah, it is okay. And then it was 1, 1, 1, 1, 1. So this is yes, vertical line test. Now, what if they were both filled in at the top and bottom there? No, then it would be no. So, and if they were both open, it would still be yes, because now it doesn't have to be in the domain. This type of function right here is called a piecewise function. All right, we got through example 2. Y'all have a splendid day. If you could still vote in your free time, that's great. If not, we'll vote again tomorrow.